So hello everyone, in continuation with the last lecture we are going to discuss now about the inverse system. So what is this? Since let hz as z simply we have discussed earlier that this is simply the relationship or the transfer function that yz upon xz. Okay, so let hz be the system function, be the system function, okay, of linear time invariant system. All right, so then its inverse, we have to talk about the inverse. Then its inverse, which should be h1z, okay, is defined if and only if the overall function is unity. The overall system function is unity. Okay, so when h1z, when hz and h1z, means the inverse of that, are connected in cascade, ठीक है, दोनों अगर कैस्केड कनेक्शन होगा तो दैट इज व्हाट डज दिस मीन्स दैट hz and h1z, this should be 1. All right, because the inverse of that is connected to the same function, then it should be equals to 1. Okay, so from here you can see that the inverse of hz should be equals to 1 upon h1z. This is a simple thing. And in the time domain, this is equivalently expressed as, in time domain, if you want to see this, in time domain, this is equivalently described as h1n convolution of n. This should be equals to delta n, the impulse function. All right, so this is all about the inverse function. So with one example we will also discuss this, then it will become more easy. Let's take one example. Simply the system is described as the difference equation, which is given by yn should be equals to xn minus e to the power minus 8 alpha, okay, x n minus 8, okay, where alpha is greater than 0. Alpha is a constant alpha greater than 0. Okay, so what we need to do over here, we need to find the corresponding inverse system function. Find the corresponding inverse function to recover xn from yn. Okay, and also check for the stability and causality. Check for stability and causality of the resulting referring function. All right, so let's see this. Simply yz is equals to, if we take the z transform of the above function, all right, so this will become yz is equals to xz minus e to the power minus 8 alpha was there, okay, z to the power minus 8 into xz. So this is simply the z transform of the above equation. All right, so from here we can find out yz upon xz, the ratio yz upon xz. If you are just going to solve this, you will get that it will be equals to 1 minus e to the power minus 8 alpha z to the power minus 8. All right, so this is what this is yz upon xz, and we all know that yz upon xz is equals to what, hz. Okay, So simply if you want to take the inverse of this, then what will the inverse of this will become? H1z will become, H1z will become simply 1 upon 1 minus e to the power minus 8 alpha into z to the power minus 8. This is simply, this is simply your inverse system of the inverse system of the above equation. All right. So this is being calculated from here that this system is both stable, both stable and causal. Why? Since all the poles of the system H1Z are inside the unit circle. इसके जितने भी poles होंगे, ठीक है, all the poles of the system are inside the unit circle. All right, that's why this system is stable and causal. All right, so let's move forward and see what is all pass system. So let's see over here that we have considered a causal stable nth order transfer function of the form this one. Okay, so here Hz is simply given by plus minus an plus an minus 1 z inverse plus and so on up to z to the power minus n, divide by 1 plus a1 z inverse plus and so on an z to the power minus n. All right, and this is we have considered equivalent to plus minus mz upon dz. All right, so let's see over here, let's see. So now dz is given over here. Okay, so if you want to see what is dz inverse, then what we have to do, we just need to put the value of z over here and change it with z inverse. Okay, so this will become what, 1 plus 1 plus a1 is there, it will become z. All right, plus a2 will be there, it will become z square, and so on, it will become a to the power n into z to the power n. Okay, this will become like this. All right, from here we can see this, we can take the common as z to the power n, and it will become like an plus an z to the power, sorry, not an over here, now it should be an minus 1 z to the power minus 1 plus and so on, it will become up to z to the power minus n. Okay, so you can see this, what is this, this is simply equals to here mz given in the above equation. So what will it will become, it will become z to the power n into mz. All right, or you can write down this as mz from the above equation should become equals to z to the power minus n due to d z inverse. Okay, and from here hence hz will become what, hz will become plus minus z to the power minus n d to the power z inverse upon dz. Okay, and hz inverse will become what, hz inverse will become what, this is simply a transform function, output upon input, so we will get this one, and the inverse of this will give us plus minus z to the power minus n d, sorry, it will become now z to the power n dz upon dz inverse. Okay, therefore from here we can see that hz into h of z inverse, this will give you what, 1. Thus h omega mod of h omega square will be equals to what, h e to the power j omega h e to the power minus j omega, this will also be equals to 1. for all values of omega. All right, so we can see that the above equation, this one, that first equation which we have taken, if you take it as equation number 1, passes all frequencies contained in the input signal to the system. Okay, this passes all frequencies contained in the input signal to the system, and hence such a transfer function is an and hence uh, uh, hence such a transfer function is an all pass transfer function. All right, now if xn is input sequence, yn is output sequence, then for all pass system, for all pass system, yz will be equals to hz xz. Okay, thus y e to the power j omega, this will be equals to h e to the power j omega into x e to the power j omega. Okay, so since we all know that mod of h e to the power j omega equals to 1, what we will get from here is y e to the power j omega mod of this should be equals to x e to the power j omega. All right, so this is what we get in the all pass system. All right, so this is all in this lecture. Thank you, and I will give you some numerical on this as a part of an assignment. Then those things will become more clear to you. So unit number 1 is complete now. Thank you. Thanks a lot.